Hi everyone, welcome to my channel. This is Mr. Cervone. Today we will be learning about circle proofs in lesson 88. If you look at the do now, we're given that segment CT is congruent to segment CH. Those two segments, when you look at the figure, are considered secants, okay? So how would you describe or show that segment HA is congruent to segment TD? And notice that segment HA and segment TD are considered chords. Okay, so let's write this down. The first thing we know here is that segment CT is congruent to segment CH, which is our given. What else can we say here? Well, if you look at the diagram, we can say that angle T and angle H are congruent. Why are these two angles congruent? These two angles are inscribed angles of the circle shown, and they both intercept the same arc. So what we can do here, write that angle T is congruent to angle H. And the reason for that is if two inscribed angles of a circle intersect the same arc, then the two inscribed angles are congruent. Great. What else can we say here? Well, here we can say that angle C is congruent to itself. So angle C congruent to angle C. And that is the reflexive property. So let's write this in. Reflexive property. Okay. Now, if you look at the given that segment CT is congruent to segment CH, and then we have these two angles that are congruent, then we can prove the two triangles that are overlapping to be congruent as well, using the ASA postulate. So now we can say that triangle CTD is congruent to triangle CHA in that same order. Okay, so the reason for that is the ASA postulate. Okay, so that's great because now we have proven both triangles congruent. Now that we know that the triangles are congruent, how do we know that segment HA is congruent to segment TD? The famous CP-CTC, but in this case, we should actually always write it out. Corresponding parts of congruent triangles are congruent. As you can see, we have just done a circle proof. Ideally, you want to write everything in a statement reason table as follows. So here is the statement reason table. There you go. Okay, so that's how you want to write your proof, as a statement reason table. You're more than welcome to write a plan like we did here. Okay, but that's really not necessary. If you don't have to, you can just go ahead and write the statement reason table in this format here. So at this point, let me give you all the theorems and postulates that you need for the circle proof unit or the lesson. So once you have studied all the theorems and postulates, what I want you to do is to go to homework 88 in Schoology and complete your homework 88 assignment, and that will be due on Wednesday. Okay. Other than that, let me introduce you with the theorems and okay, so these are all the theorems. For example, all radii of a circle are congruent. In a circle, congruent central angles intercept congruent arcs. In a circle, congruent arcs have congruent chords. Conversely, congruent chords cut off congruent arcs. A diameter perpendicular to a chord bisects the chord and its arc. Congruent chords in the same circle are equidistant from the center of the circle. Inscribed angles that intercept congruent or the same chords are congruent. An angle inscribed in a semicircle is a right angle, also known as Thales theorem. parallel lines intersect congruent arcs. If a line is tangent to a circle, then it is perpendicular to a radius drawn to that point. Two tangents drawn to the same circle from the same external point are congruent. So if I were you, I would either take a screenshot of these theorems or write them in your notes and use these theorems in conjunction with other theorems and postulates that we have learned in the previous lessons in school to complete your homework assignments on circle proofs. If you have any questions, you are more than welcome to email me. Please free to email me anytime. I've also set up a Zoom virtual meeting. If you're interested, please email me. Other than that, thank you so much for watching the video, and please don't forget to subscribe to this video using the red button. Okay? Have a great day.